Okay, so what I'm going to do now is, first of all, go through the Venn diagram and then use that to talk about the probability of events happening and all the terminology that comes with it. So let's say that there are 37 learners in the class, right? Actually, no, let's make it 40. So there's 40 learners in the class, and we say that maybe they tell you that some study maths and some study physics. And so we would represent the maths and the physics using circles. So we could have the maths there would be this circle, and the physics could be this circle. And they start by saying, well, say 10 students study maths and physics. And then they said, well, also we know that, say, 30 students studied maths. Well, if 10 study maths and physics, we know that 20 would just study maths, because 20 and 10 would make 30 studying the maths. And then they could say that 15 students study physics. So then 10 is already included in the maths, and then 5 would only study physics then. And so if we added these together, we'd get 20 plus 10 plus 5 is 35, but there's 40 in the class. So we could complete the Venn diagram. So this would be our answer to the question. They could say, complete the Venn diagram, and we would know that 5 studied neither. Okay, so now what we're going to do is look at what various things mean when they say, you may have seen this P of M equals, or P of A. Actually, they usually say P of A, but it could be anything. So probability of A is just event A. So in this case, P of M would be the event maths. So if they said, what's the probability of M? So someone studying maths in the class. Well, probability is 30 out of the 40. Because remember, probability is your outcome over the total number of outcomes. So the number of outcomes is 40 different students, 30 do maths. So then it will be 3 over 4, which you could also write as 0.75 or 75%, depends on what they ask. But usually when you get to the higher levels, they want it as a fraction, not a fraction, as a 0.075. And this is because probabilities go from 0 to 1, right? Because we can't get more than 40 people studying maths if there's only 40 people in the class. So, maths could have been just called event A. And so it would have just been P of A equals 0.75. So that's what the P of A means. All right. And then P of B, so event B, we could talk about that as being physics, but to make our lives easier, sometimes we use the letter like P of P because it just makes it easier for us to see, maths, physics, rather than thinking, well, which one did I call A, which one did I call B? So we just give them letters that help us. Obviously, you can't do that sometimes if the subjects start with the same letter. So physics would be 15 out of 40. Okay, which simplifies to divide those by 4. We can get 3 over 10, which is 0.3. That doesn't make sense. 15 divided by 5 is 3. 15, yeah, it's got to be 8. So that would be 0.375. If you could round to, we could round it to 2 decimals. I'm going to leave it at that. So that's P of M. So when you see P of M, that just means probability of something happening. If you see this P of M with a thing on the thing, right? Or A could also be A. P of A with a thing. That just means not. maths. The probability of not maths is all the people who don't do maths. Well, 30 do maths, we know that 10 don't do maths. And so we get 1/4, which is a quarter. And we see that probability of maths plus probability of not maths would add up to 1. And that makes sense because our probabilities add up to 1. And so that would be something that would be called exhaustive. So if you come across the term exhaustive, it means that it encompasses everyone. So maths and not maths encompasses all of the people in the class, and that would be events that are exhaustive. So exhaustive events add up to 1. Okay, so exhaustive events. So I'm just going to say that P equals 1, probability equals 1. So that the outcome is going to be 1. Then we can look at, so now we know what this means, not M. Now you might see this, probability of M, or well, let's do A and B. Okay, which could be, in this case, P of M and P. So what does that mean? Let's say, well, first of all, let's say what that means. That means the probability of A and B. So this is, we can think of this upside down as just, it looks like an and. Right? You just think of it as the A and the and, this thing here. So that's how I remember it. A and. So that thing means and. And so what would be the probability of M and P? Well, that would be where they overlap, right? Now, when you're doing these questions and your Venn diagrams get complicated, it's actually quite nice to shade. So if I was to shade the maths with a one color highlighter, I like to use those erasable highlighters, and then P is the physics, and I do that in blue. I could think of it as, well, where is it pink and blue? Where did the pink and blue overlap? Well, that would be the 10. So maths and physics would equal 10/40. Which is equal to 1/4, which is 0.25 for maths and physics. All right, so that would be, now if you saw this, N of M and P, that means the number of people doing maths and physics. And so that would be 10. So if you see N, a little N in front instead of P, that just means what's the number. So if you ask for N of A or N of maths, this would just be the number of people doing maths, which is 30. So if you see that little N, just know that that means a number of people. But they're more likely to ask probability, but you do see it. Actually, it's more in the GCSE syllabus. Okay, let's make a bit of space. And let's go through this, a couple of things now with the rules that they tell you. Okay. So you may see this. Probability of A or B. Okay, well, let's just go to the, this is one more notation. So A or B, this union B means or B. So that means the probability of A or B. Now, if you remember the and B, you just know the other one is or. So because there's these two options, so and or. So or, if I said M or P, well, that means where is it pink or blue? So it could be any, it could be all of these, right? Union, it's all of them. Because that's pink there, that's blue there, and this is or as well. So this is and, but it also counts. So we can say that wherever we see it shaded, that's going to be part of the probability. So there's 35 in total there over 40,
Okay.
which is divide those by 5, so it'll be 7 over 8, which is 0.875, right? Okay, so that would be the probability of M union B. And from this, they developed this formula, this rule, which is the probability of A or B is equal to the probability of A and B. Oh, sorry, let's start with, that comes at the end. Probability of A plus probability of B minus the probability of A and B. Now, I know this off by heart because when you look at a Venn diagram, it actually makes this thing very easy to understand. If I look and say, what's the probability of an A or B? So we already know that A or B is this whole bit in here. Okay, that's 35. Well, if I look at it, it's the pink bit, that pink circle, which I've circled, plus the blue circle there. Well, that makes sense. But I'm minusing the middle. Okay, I'm minusing the middle. And why? Because when I do the pink and the blue, technically I'm counting them twice, right? Because the pink is 30 and the blue is 15. But that means I've counted the 10 twice. So if I need to minus one of those 10s. So it's like pink, blue, and then minus the middle, because when I did pink and blue, I counted the middle twice. Does that make sense?
Yes.
Sure, because I can go over it again. That's why we
No,
minus.
no, I get it.
Good. That's why we minus the middle. Okay. And so we minus the middle. So that's that rule, right? And it's pretty interesting because from that rule, we can get another thing when we talk about mutually exclusive events. So we've heard about exhaustive, which includes everything. Mutually exclusive. Think about exclusive. It means that you cannot, actually, it's not actually that obvious. But mutually exclusive events means that you can't be one and the other at the same time. So, for example, heads and tails on a coin. You can't throw heads and tails at the same time. You either throw heads or tails. So they're mutually exclusive because they don't overlap. And you could, it's a number of things that are mutually exclusive, right? If you took the ages of people in a class and some people were like 9 and others were 10, well, those would be mutually exclusive because you can't be age 9 and 10 at the same time. You're either at 9 or you're 10. And so there would be no overlap because there'd be no 9 and 10-year-olds. There'd only be 9-year-olds and there'd be 10-year-olds, but they wouldn't overlap. And so that Venn diagram, I'm just going to do it very small. That Venn diagram would actually look like this because they don't overlap. Or you could just think of it as this middle being 0. Right? Does that make sense? Because there's no overlap.
Yeah.
So when we look at mutually exclusive events, we see that this bit here, this and B is 0. And so mutually exclusive events, the P of A and B is 0. And the other thing we can say just from this is that A or B is just equal to PA plus PB. Because the minus P and B is 0. Does that make sense?
Yeah.
So the probability of a nine-year-old or a 10-year-old would be just the probability of 9-year-olds and 10-year-olds added together. Okay, and then there's independent events is the last thing. And so we're just going to look at that. Now, all of this probability that we're doing, if you understand this, you're actually going to do nicely for your matric, because this is pretty much the Venn diagram and probability stuff for matric. You do other stuff like counting principles, but this, if you understand this probability, you're going to get, there's about a 12 to 15 mark section that's on this stuff. So if you learn it well now, you basically have learned it for matric. So the last thing is that the PA and B, if the PA and B equals PA times PB, then you have independent events. Now, a lot of students actually get away with not understanding this. Because we've got the one rule that says PA and B, PA or B equals PA plus PB. Remember this rule we just did, minus P of A and B. So sometimes what they'll do is they'll give you PA and PB, and they'll tell you that it's independent. And so basically, if they tell you it's independent, then you know, and they told you this was, say, a quarter and this was 3/4, they're giving you that and they're giving you that. And then if you know that independent events means that PA and B is equal to that, you know that this bit here as well, you know, as well, because that is just a quarter times 3/4. And so even without understanding it and just knowing these two rules, students are able to get by. But it's better to understand it. So let's look at what that means. Well, what is independent could be, you throw it ahead. Oh, sorry, you toss a coin and they want the probability of getting ahead. And then you throw another coin and it's maybe a tail. Oh, sorry, no, let's make it, you throw a head and then you roll a dice. And you could get and it's a 6-sided dice. And so they said, what's the probability of getting a head and then a 3? Well, the probability of getting a 3, there's 6 sides of the dice and only 1 3, so it'd be 1/6 would be that probability. So let's just say P of H, a head, is equal to 1/2. The probability of a 3, when you throw the dice, is 1/6. Now, because these are independent events, what's the probability of I throw a head and a 3? Well, a head and a 3. Because they're independent, right? Because if I throw a head, that has no influence on when I throw the dice, right? Because anything you did before throwing a dice doesn't affect what you, if it's an even dice and it's not loaded and it works like a proper dice, that you should theoretically, if you throw it enough times, find that everything, kind of those probabilities of each number is 1/6. So the probability of a head and a 3 is equal to the half. Once you've thrown that times a 6, and it's 1/12. Okay, and what I want to do is just go a little bit further into this and just show you why this is true. So let's look at me throwing a head, right? So if I throw a head, I could throw a head and then a 1, or I could throw a head and then a 2, or I could throw a head and then a 3, or a head and a 4, a head and a 5, or a head and a 6. And these are all, because it's an even chance of heads and an even chance of the numbers, well, not an even chance, but a 1 in 6 chance of the numbers, in theory, these are the outcomes. These are the possible outcomes. T, you can throw a tail in a 1, a tail in a 2, tail in a 3, tail in a 4, tail in a 5, tail in a 6. So remember, probability is the outcome that you are asking about over the possible outcomes. So we see that there's 1, 2, 3, 4, 5, 6 times 2 is 12 outcomes. There's only one outcome that gives us heads and 3, and that's that, which is 1 over 12. So if they're independent events, we see that heads and 3 is the same as multiplying the probabilities of each together, which was a 6 times a half.
Okay.
Okay, so that's probability. I think that's going to be quite a long video. Might just upload this video actually, and then just send you the link.
Yeah.
But yeah, I will see you again next time. In actually, no,
Alright.
in what, 4 hours, 5 hours, something like that.
Yeah, a few hours, not too long.
Okay, so the plan, go to Santon, and then you're going to, oh, let me just stop recording here.